What's up guys, this is Massey. Welcome to another video. In this video I want to talk about even functions and odd functions. So let's take a look at the definitions first. Functions that have the property expressed by the equation f of negative x equals to f of x are called even functions, and functions that have the property expressed by the equation f of negative x equals to negative f of x are called odd functions. And the third case is gonna be many functions satisfy neither even functions characteristics nor odd functions characteristics. So in this case we just mention neither. An even degree polynomial function which exponent of each term of the function is even is an even function. An even function is symmetric about the y-axis, and we have line symmetry, so that belongs to even functions. So even functions are line symmetric around y-axis, and also all terms of having x to the power of even number. On the other hand, we have odd degree polynomial function is an odd function which exponent of each term of the function is odd. An odd function is symmetric about the origin 0, 0, and we call it point symmetry or rotational symmetry. Let's see some examples. Question 1, let's say f of x equals to x squared plus 3. We want to see if it's odd function, even function, or neither. So first of all, I'm gonna write f of negative x, so it's gonna be negative x to the power of 2 plus 3. So instead of x, I just need to sub negative x. So x squared is gonna be negative x in bracket squared plus 3. 3 doesn't have x, so it remains the same. Negative x to the power of 2 is gonna be positive x to the power, because any negative number to the power of even number is gonna be positive. So that's going to make it as x squared plus 3. So f of negative x equals to f of x. We're going to say that's the even function. Second example. F of x equals to x cubed minus 5x. Just gonna find out f of negative x. So negative x to the power of 3 minus 5 times negative x. As you see here, instead of x, I just put negative x, negative x. So negative to the power of odd number, so it remains as negative x cubed, and negative times negative is gonna be positive. So when you factor negative, it's gonna be x cubed minus 5x. So as you compare with f of x, we can conclude f of negative x equals to negative f of x. So we have odd function in this case. Next example. F of x equals to x squared minus 2x plus 1. In this example, I'm going to write f of negative x. That's going to be negative x to the power of 2 minus 2 times negative x plus 1. That's going to be x squared plus 2x plus 1. On the other hand, I need to, that's definitely not even function, because this and this equation are not the same. So let's write negative f of x. If these two are the same, we're going to say we have an odd function. So that's going to be negative x squared minus 2x plus 1. So it's going to be negative x squared plus 2x minus 1. So that's also not correct. So this is going to be neither. Next example, f of x equals to x cubed minus x squared plus 5x minus 1. So f of negative x is going to be negative x to the power of 3 minus negative x to the power of 2 plus 5 times negative x minus 1. That's going to be negative x cubed plus x squared minus 5x minus 1. Since they are not the same, so I'm going to say f of negative x it is not equal to f of x, so it is not even function. If we manage to write negative f of x, it's going to be negative times x cubed minus x squared plus 5x minus 1. That's going to be negative x cubed plus x squared minus 5x plus 1. So that's not equal to this guy as well. So it's not going to be odd function as well. So we're going to say it is neither. Next example, f of x is going to be equal to negative x squared plus 10. I'm going to write f of negative x, negative x squared plus 10. So as you see here, x, instead of just x, I wrote negative x. So that's going to be negative x squared plus 10, which is the same thing. So that's even function. Next example, x to the power of 5 minus 3x to the power of 3 plus x. So I'm going to say f of negative x is going to be negative x to the power of 5 minus 3 times negative x to the power of 3 plus negative x. So that's going to be negative x to the power of 5 plus 3x to the power of 3 minus x. So f of negative x is not going to be equal to f of x. So it's not an even function. Let's take a look to the odd function, which is going to be negative times the whole thing in here. So negative times x to the power of 5 minus 3x cubed plus x. That's going to be negative x to the power of 5 plus 3x to the power of 3 minus x. So this and these are equal. So f of negative x equals to negative f of x. So that's going to be an odd function. Next example, f of x equals to 3x to the power of 6 minus 2x squared plus 3. Let's say f of negative x is going to be 3 negative x to the power of 6 minus 2 negative x to the power of 2 plus 3. That's going to be 3x to the power of 6 minus 2x squared plus 3. So f of negative x equals to f of x. So that's an even function. Next one is f of x minus 5, absolute function of x minus 5. So we need to find out f of negative x first. So it's going to be negative x minus 5, which is going to be negative x plus 5 in absolute function. So as you see here, f of negative x is not equal to f. And if you write negative f of x, it's going to be negative absolute value of x minus 5. So that's going to be neither. Next one, we have f of x equals to absolute value of x plus 3. So I'm going to write f of negative x, which is going to be absolute value of negative x plus 3, and that's going to be the same as absolute value of x plus 3. So we're going to say f of negative x equals to f of x. So we have an even function. Next example, f of x equals to 4x times square root of x squared minus 1. And here we have f of negative x, that's going to be 4 times negative x times square root of negative x to the power of 2 minus 1. That's going to be negative 4x x squared minus 1, which, as you write negative f of x, that's going to be exactly the same thing. So f of negative x equals to negative f of x. Definitely that's then odd function. What about trigonometric function? F of x equals to sine x. F of negative x is sine negative x, which belongs to quadrant 4, and in quadrant 4 sine are negative, so it's going to be equal to negative sine x. So that's an odd function. Now let's take a look to cosine function. Cosine x. F of negative x equals to cosine negative x, and cosine function in quadrant 4 is gonna be positive, so that's gonna be equal to cosine x. So we're dealing with an even function. What about tangent? F of x equals to tan x. So f of negative x equals to tan negative x. Quadrant 4, tan r based on the cast rule is negative, so negative tan x. So we have an odd function. Next example, f of x equals to x to the power of 4. So we know anything to the power of even number is going to be even function. So f of negative x equals to f of x. That's an even function. Next example, f of x equals to negative 6. F of negative 6 is going to be the same thing, because we don't need to change it because it's not depending on x. So f of negative x equals to f of x. So that's even function. F of x equals to x to the power of negative 3. So we can say f of x equals to 1 over x to the power of 3. F of negative x equals to 1 over negative x to the power of 3. That's going to be negative 1 over x to the power of 3. So that's an odd function, because that's equal to negative f of x, which is negative 1 over x to the power of 3. So that's an odd function. Next example, y equals to absolute value of x. Absolute value is an even function. How? F of negative x equals to absolute value of negative x, which is going to be absolute value of x. So f of negative x equals to f of x. So that's an even function. Next one, f of x equals to 1 over x squared plus 1. So f of negative x equals to 1 over negative x to the power of 2 plus 1, which is going to be the same thing, 1 over x squared plus 1. So f of negative x equals to f of x. So we have an even function. Next one, f of x equals to x times x squared plus 3. We say f of negative x equals to negative x times negative x to the power of 2 plus 3. Again, we are changing x to negative x. So then you simplify it. That's going to be positive, negative x squared plus 3. So as you see here, that's going to be equal to negative f of x, which is going to be exactly the same thing. So since negative f of x equals to f of negative x, we're going to say we have odd function. Next one is, just going to go to the next page. F of x equals to absolute value of x over x squared minus 5. So f of negative x is going to be negative absolute value of x, negative x to the power of 2 minus 5. That's going to be x over absolute value of x over x squared minus 5, which is the same thing. So f of negative x equals to f of x. So we have even function. And the last example, f of x equals to absolute value of x over x cubed plus 1. So f of negative x equals to negative absolute value of x or negative x cubed plus 1. That's going to be absolute value of x over negative x cubed plus 1. So f of negative x is not equal to f of x, so that's not an even function. Negative f of x equals to negative absolute value of x over x cubed plus 1. So that's not going to be even equal to f of negative x, so we're going to say neither of them. So these are some examples related to even function and odd function. I hope you enjoyed this video. Please leave me a comment if you have any question, and please don't forget to subscribe this channel. When you subscribe, you have access to many other videos regarding math, physics, and chemistry. Thank you for watching and have a great day.